Hello, Sam here with a brief couple of lectures on overloading and polymorphism. Just a quick break from Ben's main project, and we're going to be talking about these concepts in C++ just to solidify your knowledge. Okay, so in this video, we are going to be talking about what is polymorphism in the first place, both in the general sense and in the specific senses used in C++. How to overload your functions and using runtime polymorphism, and how both of these concepts relate back to polymorphism in the general computer science sense. So let's begin with talking about polymorphism and how we can define it. It's a really slippery concept and very hard to define. Believe me, I've tried quite a few takes on this video to try and define it. It's just not coming out right. So it's easiest to understand polymorphism in terms of the different types of polymorphism. Now, there are three main types, and we're going to be talking about two of them today, but let me just overview what the three main types are. The first one is called ad hoc polymorphism, and this is when you have different implementations for different type signatures of your method. So you might have one name for your method, but it might take different input parameters, different types as its arguments, and then you would have different implementations based on those different types. So basically, it's a completely different function, but it's specified by the type. Then we have subtype polymorphism. Now, this is a clever one, and it's quite a clever one in C++, where you can have parent pointers that point at instances of the children classes, and they can be passed around and used in functions as if they were the parent pointers, but they behave like the children. So that's a very interesting type of polymorphism. We use that a lot, especially, for example, with actors. You can pass around an actor and you can use it without knowing what type of actor it is, whether it is going to be a tank or not. You can just treat it like an actor and it will do the right things. And then if the tank has overridden any functionality, it will do the right thing. And then you've got parametric polymorphism. This is the type we're not going to be talking about today. We'll be talking about it in the next section. So hang on for that. It's where we'll be talking about templates and such like. And here it's as opposed to ad hoc polymorphism where you have different implementations per signature. Here you have one implementation but multiple signatures. Now that's a bit of a muddler that we're going to leave with you because we aren't going to be tackling it in this lecture. Okay, so let's dive in and create a basic project to get started with. Now I just wanted to say before we start that this blog post is incredibly helpful for understanding. Here he's actually talking about 4 types of polymorphism. You can go into more details if you want to. The link is in the resources. I'm going to go over into Visual Studio and start up a new project here. I'm going to go to File, New Project, and because this isn't based off anything that Ben's doing, you aren't going to see this showing up in the GitHub resources. Now I'm going to go to Windows Console Application, and I'm going to give it a sensible name like Polymorphism Demo, and let's go ahead and click OK and load up that project. So to get started with, I want to give you a demo of how we might use ad hoc polymorphism. So what I'm going to do is I'm going to create a function called getSize. It's going to be int getSize, and you can pass it something, which in this case we are going to pass it an int called x. And then what we can do is in our main, we can do a std_cout. Remember, we're just using clean C++ here, so we have no UE logs or anything like that. So I'm going to have to include, if you can throw your mind back to when we were doing pure C++, it's iostream to use std_cout. And then what we can do is we can just print out the get size of 5 and do a stud endline, like so. Now, okay, that's pretty straightforward, and in fact, let me implement getSize. Pretty easy, just return x, like that. Tells you the size of x, pretty much simple. So there's no complications here. In fact, it's trivially easy. But what I want to show you is what happens when we get some ad hoc polymorphism involved. So here I want getSize to also be able to take a string. So I might pass it hello world, and I want it to be able to respond with the size of hello world. But as you can see, this is giving an error because it's the wrong type. Well, in ad hoc polymorphism, all we have to do is give it another implementation for the string. So what I do is I copy and paste my getSize implementation, and I replace the type of the parameter, which was previously int, and I replace it with std_string instead. And now I need to implement my method differently. But you can see that already in the main function, it stopped complaining, because what we've done is we have overloaded our getSize function, and that is the language feature that C++ uses for ad hoc polymorphism. It's called overloading. So if you hear the term overloading, that is what it means. And if you hear the term ad hoc polymorphism, you can link it back to the language feature called overloading. Now, there are some other things to note here. Subtype polymorphism in C++ is typically just known as polymorphism. And so if you are looking at this lecture and thinking, why is he calling that polymorphism? I thought polymorphism meant something else. Well, that's because in the C++ sphere, it tends to mean this specific subtype polymorphism. But in the general computer science sphere, subtype polymorphism is just one type of polymorphism. Anyway, we'll get to subtype polymorphism. I'm getting ahead of myself. So getSize we need to implement. It's going to be dot length of the string passed in. And if we go ahead and build that, yes, build, and go and have a look at what the output is, we will see that it returns 5 for the int, which is unsurprising, and it returns the length for hello world. So you can see that 2 different implementations are being called depending on the type. So that is ad hoc polymorphism, or overloading is the language feature in C++. Now, how do we do subtype polymorphism, and why would we want to use it anyway? Well, imagine that I have a function such as it's going to be void, and it is going to be called stroke, and it is going to take an animal called animal, and it does something. Okay, so it's just a function. It takes an animal and it strokes it. Fairly straightforward. Now, actually, let's pass it a animal pointer, because we don't want to be copying the animal around. That will break polymorphism in C++, and I've got a little challenge to you later to show you why that's the case. And let's actually declare our class animal, like so. Okay, so this now looks okay, and what I want to be able to do in my main method is to declare some animals. So I can have an animal called dog, and an animal called cat, and I should be able to stroke the dog, and I should be able to stroke the cat, like so. Okay, that's pretty straightforward. That should work out. It's obviously giving me an error because I haven't actually implemented my animal. So let's go ahead and implement my animal class, like so. And that won't give me an error anymore, but stroke doesn't have a body, so we need to implement the body of stroke. And the body of stroke, I'm actually going to create a function in animal, which is going to be public. So let's give it the public specifier. And it is going to be make noise, like so. It's going to return void because it's not going to return anything. And it is going to have a body that basically, if we can fix my indentation here, it is just going to print out a noise. And in this case, it's not going to print out the size of hello world. It's just going to print out animal noise, like so. Okay, so we've got a class, we've got make noise, and in stroke, what we want to do is take our animal pointer and use our arrow operator to call make noise on that animal pointer. Okay, and this should work out. We've got an animal dog and an animal cat, and we can stroke both the dog and the cat. That makes sense because they're both the same type. They're the type that we're passing in. In fact, we need to get the address of dog and the address of cat. That's why it's complaining at me right now. And if we go ahead and control F5 and build it and print it out, you can see that we get animal noise for both of those functions. So far, there is nothing new there whatsoever. We've got a class, we pass it in by pointer to a function that then calls a method on that class. Nothing absolutely new. But if we decide that our cat and our dog are actually going to be of different classes, but both of which are children classes of animal, and make different noises, then things get more interesting and we're going to start using subtype polymorphism. So let's go ahead and create a subclass animal called dog, first of all. And what noise is it going to make? It is going to make a woof sound because it is a doggy woggy. So woof, that's what the dog makes. And then we'll go and, this is sounding like a nursery class, isn't it? And then we're going to go and do a cat, and that is going to make a meow sound, like so. Okay, and you will notice, let's just do something. So I've got the dog is of type dog, the cat is of type cat. You'll notice it's now complaining when I get the address of the dog and the cat to stroke them, because it says that there's an incompatible pointer of dog star and animal star. That's because I haven't overridden, I haven't derived from animal with dog and cat. So I can do this by using the inheritance, public inheritance that you have seen before. So it's going to be dog public colon public animal and cat colon public animal as well, which will then mean that both of the cat and the dog are child classes of the animal, and it's fine to pass it into stroke. It's fine to pass in a child pointer to an instance of a parent pointer. So you see stroke, we haven't had to overload it like we've done with int and string. We've used one implementation for all of the subtypes of animal because they all have a make noise class. Now, what happens though if we F5, build it, and run it? You'll notice that it's still making an animal noise, and that's because you need a virtual function. So let's just have a look at this table one more time. We're looking at the moment, subtype polymorphism, which in C++ is often known just as polymorphism or runtime polymorphism. And the language features we're looking at are subclasses and, virtual functions. You've just seen virtual functions. So what I'm going to do is actually go ahead and challenge you to make these animals behave themselves and actually speak like they should be speaking. So each should call the right behavior and print the right thing. And I'd like you to see what would happen if we weren't using a pointer. Pause the video and have a go. Okay, welcome back. So let's give this a shot. So the first thing is trying to make it virtual. So if you remember correctly, then there is a virtual that we want to put in front of the parent class's make noise function. And then in the children classes, we want to, well, actually this will just work, but just to make sure that we are in fact overriding something from the parent class, you can use the override keyword after the function, which will just double check that indeed the parent class has a virtual function that matches this make noise function and that we are overriding it. So if we go ahead and Control F5 to build and run without debugging, you'll notice that now we have got woof and meow being printed out when their stroke method is called on the pointer. Now I just want to really hit this home that it does indeed need to be a pointer, because what happens if it is not a pointer? If I remove this star and I don't do address of for cat and dog, in C++, what this is doing is it is deciding to take a copy of the dog and the cat. But you'll notice that because it is in stroke we are passing in an animal, it is making a copy of it as if it were an animal, which means that when we call animal dot make noise, it is going to assume that what we have is an animal, because it's a copy of this thing as if it were an animal, and it will call the make noise function. Let's just check that. I'm pretty sure, but you might not believe me. There you go. It calls animal make noise. But another interesting thing just to note is that we've been using pointers, but you could equally well have used a reference to the animal, and this will also use the polymorphism correctly, the subtype polymorphism I should say. And if I do Control F5, build it and run it, there you go, you've got woof and meow. So pointers and references, okay, we'll be using subtype polymorphism. If you use copies, then it can't, because you've lost any information about what the original type was. Great stuff. So we've learnt a lot in this lecture. We've learnt about ad hoc polymorphism. We learnt about subtype polymorphism and how virtual and subtypes fit into using that. So I look forward to the next lecture where we're going to be showing you a little bit more about why we have to use this virtual keyword. Why isn't that just the default behavior? And I'll see you there.